Okay, we begin a new unit today, but as always, it relates directly to the unit right before it. However, the unit right before it, we spent most of our time graphing real-life situations. Whereas this unit, we're going to be spending all of our time graphing just equations, because the skill of graphing equations will help you with the skill of graphing real-life stuff. You five can hear me, right? Okay, that's all I care about. So I'm going to go ahead and start with this, and then we'll move on. Now, one sec. We already know what the X-Intercept is. What is it actually? What is the X-Intercept?
Line that goes through the x-axis.
Yeah, it's where your graphed line goes through the x-axis, right? So we already know that part of it. We know that the X-intercept is any time a graphed line crosses the x-axis. Now, how many x-intercepts will there be if it is a straight line? Just one, right? Because to hit it again, it would have to bend. So for our intents and purposes, there is one x-intercept per equation, because we are only using linear equations. Now, every x-intercept, and I'm going to write every in big capital letters, and I'm going to highlight it, and I'm going to put a Mrs. Bad Crumble cloud around it. How important is that word? Exactly. Every x-intercept has, oops, I did too many T's there, has the same coordinates. And those coordinates are as follows: x, comma, 0. Why is that an x? Because you don't know the x. Why is the y value 0? You do know the y. That's why it says 0. Why is it 0? That is exactly right, Amy, but how about you put that into words? Because we're not all deaf. Exactly. There is the x-intercept. Do you have any idea what that x coordinate is? No, because I have not put a scale on there. But you know that that is 0 for a y coordinate. Nice job, team. Amy's the idea person and Haley's the spokesperson. Okay. Now you guys are smart kids. A y-intercept is the same thing, but crossing the y-axis. Now, once again, every, highlight, Mrs. Bad Crumble, every y-intercept is what? No. Those are the x-intercepts. The y-intercept is y, comma 0. We'll put the y's first. 0, comma y. Guys, I have to take this phone call because it might be the guys fixing my van. Hello. Speaking. Hello? Okay. 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 We are gone for the entire month of August. It would have to be in September. If we need to be there, both my wife and I work, but couldn't care less. Well, school doesn't start. Actually, school doesn't start till the 5th. The last week of August would be fine. The 28th to the 1st. 28th of August to the 1st of September. Anywhere in there would be fine. Sure. Yep. Okay. Sounds good. No problem. Bye. It wasn't the guys fixing my van. It was the guys cutting down a tree in my backyard. They can't do it. The guy that cuts down the trees fell out of a tree yesterday. Ironic, I know. All right, back to business. Go away. Go away. There we go. So. Huh? How do you spell coordinates? C-O-O-R-D-I-N-A-T-E-S. Oh, we gotta wait for a moment anyway because the computer is frozen because I did more than one thing with it. 2017 Microsoft's flagship computer. Can't do more than one thing with it. You know what I should do? I should put a bunch of copyrighted Microsoft stuff in my notes. And then when I put it on YouTube, their lawyers will find it. And then maybe their lawyers will watch it. And then maybe their lawyers will say, this guy uses the Surface and it sucks. Maybe we should fix it. It's not a bad idea. Microsoft, your computer sucks. You know who makes a good computer? Lenovo. Oh, really? All right. So, everybody, in this big blank spot here, draw yourselves some coordinates. Draw yourselves a line. Now, that is a linear function, yes? How do we know?
Straight line.
It's a straight line, right? How do we know it's a function? Because you do the straight line test, right? See how I'm giving you all these little hints for your test that's coming up later today? I know, right? It's my Grinchy heart, 2 sizes too big. What are the coordinates of that point right there? X, 0. What are the coordinates of that point right there? 0, y. Which means if I made a table of values or a t-chart, that means I could put x, 0 and 0y into it, right? Now this line, when we write it out as an equation, we know that it's going to have an x and a y and maybe some other numbers, correct? So, we know this line is x, y, possibly another number. I'm going to call it c. What do we know about that and that in relation to that? If I want the X-intercept, what would I do with those two values and this line? You would put x for x and 0 for y plus whatever C is, and then you could solve to find the missing X. I know it's not working. I have eyes. Thanks, man. There it is. What if I wanted the Y-intercept? Then what would I write? Then I would have 0 plus Y plus C, and I would try to find the Y. Does everybody understand? What's not to understand, Amrit? Because the first one, we had 0 for Y, but we didn't know X. For the second one, we had 0 for X, but we didn't know Y. Okay? Okay. Now, let's go on and find this. What is weird about the way that is written if you hadn't had your class yesterday? Fx instead of the letter Y, yes? So if we were making a table of values for it, Ekdeep, in grade 9, it would be X and Y, wouldn't it? We're not in grade 9 anymore. It's X and f of X. F of X is the same as Y, though. Okay? All right. So this says to find the intercepts. What are the intercepts? One of them is x0. What's the other one? 0y. Now, take those coordinates and put them into the equation. We're going to do the x-intercept first. So x, that means we are looking for the f of x, isn't it? Which equals 2, what do I write here? No. X is X is X is X. So what do I write here? X plus 3. Now, what is this? 0, because the chart tells us the f of x is 0. So I have 0 equals 2x plus 3. How do I solve that? Algebra. So it's minus 3 equals 2x, and x equals negative 3 over 2. That is what x equals. So what can I write there? Negative 3 over 2. Does that give me some coordinates? That wasn't supposed to be a red line. Piece of crap. Does that give me some coordinates now? Coordinates of Shut up or get out. You have 1 second to decide. 1, 0. Which is it? Good. Now that I have coordinates, I can put them on the graph, can't I? What is weird about those coordinates? There's a fraction. Who is in charge of this graph? You are, right? Do you have to make this 1? No. Since we have a fraction, it would be smart not to make that 1, wouldn't it? So I'm going to make 2 squares equals 1. Which what does that mean 1 square equals? A half. And I need to go to negative 3 halves on the x, don't I? So that would be out 1, 2, negative 3 spots. Does everybody understand what I have done? The reason I have done that is because fractions make it difficult to graph. Harmeet. Well, 1 square is worth a half, and I need 3 halves. So I went out 1, 2, 3. Got it? All right. Now, over here, I have f of x equals 2x plus 3. Yes? All right. What can I put in that one? X is now 0, yes? So I can come over here, and I want the f of 0, which is what? 2, what do I put there? 0 plus 3, correct? Okay, so what is the f of 0? And f is our y value, isn't it? So our y equals 3. So where do I put the other dot? At 0, 3. Now, what have I done to my scale here? 2 boxes equals 1, right? So I can't put my 3 there, can I? I got to put it up 6. Does everybody understand why? And then I connect the line. Because this is continuous data, isn't it? I can take any x value, multiply it by 2, and add 3. So I have to connect the line. Is everybody good? Okay. What are the domain and range of that? X is all the real numbers, because I can put every single number in there, multiply it by 2 and add 3. And y is all the real numbers. Okay? If it is a linear function, and it's not real life, it's a math function, it's a math class function, not real life, then the domain and range is always all real numbers. Is everybody with me? In real life, it wouldn't be all real numbers, would it? Because, like when we did the pizza toppings, you can't have negative pizza toppings, nor can you have infinite pizza toppings, nor can you have fractions, right? But in math class, it's going to be everything. Everybody cool? Okay. Here we have another one. G of x, I want to know the intercepts. Does it matter that it is g of x now? No, we follow the same rules. So I remember that my x-intercept is x, 0, yes? And my y-intercept is 0, y. Then all I do is fill it in. I don't know the x, so it's going to be 0 equals 1/2 x minus 2. Solve that. Add 2 to both sides. 2 equals 1/2 x. X equals 4. And while we wait for the computer to catch up, I now will ask you this. Should I put that point 4, 0 on the graph yet? Why not? I might have a fraction, right? So I might have to change the scale. So I'm not going to put that on there yet. You with me? Okay. The y one is, I know x this time, so it's 1/2 0 minus 2 equals y. What does y equal? -2. What is the coordinates? 0, -2. And then I graph it. Because I have no fractions, I can leave the scale as it is. 1, 2, 3, 4. And down 1, 2. What do I need to do with that now? Draw the line. Why do I draw the line, Fawaz? Pardon? Is it continuous data? Can I take every single number in the universe, cut it in half, and subtract 2? Yes. So I connect the line. Now I want you to notice something. If you were in the 9th grade last year, this is your first time taking grade 10, you will not have seen what I'm about to show you. Well, you might have. If you're in grade 10, you already know this. You should have noticed that twice now, and if it happens in math once, how often does it happen? Always. Twice now, that value has been the y-intercept. Right? Because when x is 0, the x drops out, doesn't it? So keep that in your mind as we move along. Well, we won't move along yet because once again, does this right here look like this? Do those two things look the same? Yes, they do, don't they? I have an output. I have an output. I have a coefficient. I have a coefficient. I have an x. I have an x. I have a constant. I have a constant. Right? Looks exactly the same, doesn't it? And we just discovered something. When I write a function this way with a coefficient and an x and a y by itself, this becomes my y-intercept, doesn't it? Twice through our experiments. So what can we now say if we ever see an equation written this way? What can we say about that one? That is the y-intercept every time. And guys, for some reason, that this particular piece of knowledge, I don't know why, but it falls out of your heads. I don't understand it myself. Now, you guys are smart kids. You know that that b is the y-intercept, yes? What else do you see in here? You see an x and a y, don't you? X and y are coordinates, aren't they? So if I have a point on the graph, the point on the graph is going to be x comma y, isn't it? Everyone agree? What does that mean? If I have 3 comma 2, where can that 3 go? To the x, because that's an x value. Where does that 2 go? To the y, because that's a y value. Is that complicated? No. Every time you see this, you automatically have an x and a y for your equation. Always. And yet, kids tell me, I don't know what to put in for x and y, Mr. Myers. Do you have coordinates, I say to the kid? And the kid said, yeah. What are the coordinates made up of? Oh, they're an x and a y. What's in the equation? X and y. So what do you write in instead of x and y? I don't know. That's what I'm asking you. See the problem? Those are called the x coordinate and the y coordinate. That's a letter x and that's a letter y. Does everybody understand? Good. So what's the only thing left there that we haven't talked about? M. M is slope. Now, if you haven't done grade 10, this is going to be news to you. But it's not really going to be news to you because you've already seen it. Last unit, we called that rate of change. And it was how much it changed, how much the IV or the dV changes per IV changes. Now, in the last unit, it was always the IV changed by how much? We always wanted the IB to change by what? 1. Because it was always a speed or a rate or something, right, Sydney? Because that was real life. Is this real life or is this math class? Math class. So that IV change might not be 1. Everybody cool? All right. So here is a line, yes? If that line was on a graph, that point right there would have what coordinates? Do you know what coordinates it has? So what coordinates does it have? No, that would be knowing it. X and Y. Excellent. That is X and Y. Agreed? Okay. Then up here, I have another point, don't I? Everyone agree? Do you know its coordinates? No. Can its coordinates be X and Y? No, because I've already given an X and Y, haven't I? So this guy's got to be still X and Y because we don't know, but it can't be the same X, Y, can it? So there's a lot of things we could do. We could give it different letters. We could give it, what we actually do is this though. We call this guy 1, this guy 1, and we call this guy 2, and this guy 2. Is everybody cool? Now, how would you describe the change that gets from here to here? What happens, because remember, my change has to be my dependent variable changes divided by my independent variable changes. So which is my dependent variable, X or Y? Y, right? So we know that slopes have to be the dv over the iv, correct? So we're going to check with our y's first. To get from y1 to y2, how do I get there? Do I go up or down? To get from y1 to y2. Up. On a graph, what is up? Positive or negative? Positive. Excellent. Then, to check my independent variable change, how do I get over here? I go right. Is right positive or negative? Positive. So, that means if my dv change is positive, and I divide it by my iv change, which is positive, then this is what we call a positive slope. Is everybody cool? Because both of the changes are positive, therefore the rate of change is positive. Now somebody always says here, Mr. Myers, well, if we go the other way. Okay, let's go the other way. What do I have to do with my y's to get from y2 down to here? Down, which is what? Negative. Then what do I do with my x's to get over here? Go left, which is what? Negative. What is a negative divided by a negative? Negative divided by negative is still a positive slope. Is everybody good? For some reason, this is difficult. I don't know why. You guys are smart kids. What's happening over here? That's x2, that's y2, that's x1, that's y1. If I want to get from there to there, what do? I go that way, which is negative, correct? I mean positive, because I went that way. And then I go down, which is what? Negative. Two different signs means what? A negative slope. Is everybody cool? Sydney. Yes, absolutely correct. Everybody good? Okay. What is different about the third line? Do I still have x2, y2, and x1, y1? Yeah, I still got two different points. Well, it's not perpendicular, Amy, because it's not crossing anything. It's vertical. You are. You're actually 2 lessons ahead of where we are. But that's okay. Do I still have the 2 points? I do, don't I? Okay. So to get from y to y, what did I do? From y2 to y1 is what? Negative, right? To go down there is negative. Agreed? Did my x's change? No. So this one would be a negative divided by 0, wouldn't it, David? Is that allowed? Why can we not divide by 0? No. It would actually be infinity. It doesn't exist, right? And if you don't believe me, you can check. It's easy to check to prove it. I always like to prove this to kids here because kids are like, no, if you divide by 0, it's 0, Sir Myers. Okay. So 10,000 divided by 1 is what? 10,000. Everyone agree? Okay. So 10,000 divided by 0.5, which is less than 1. Is everyone cool? What's that going to be? No. It's 20,000. Because you're dividing it by half. You're dividing it by a fraction. Now, what's half of a half? Half of a half is a quarter. What happens to the answer? Oh my God, it goes to 40,000. Right? What's 10,000 divided by 0.1? 100,000. What's 10,000 divided by 0.00000000001? Is that almost 0? It's pretty darn close to 0, isn't it? Look at the size of the number. It's a trillion. Does everybody see? As you get closer to 0, your number gets bigger and bigger. But you will never be able to divide by 0 because it is infinite, which makes sense here, doesn't it? Straight up and down is an infinite slope, yes? That would be very difficult to ski. You would not ski that slope. You would fall that slope. Does everybody understand? So this, since it's infinite, we say that it is undefined. So I have now given you 3 ways to describe slopes. They are positive, they are negative, or they are undefined. But you guys are smart kids. There's 4 lines here. So there must be a 4th way to describe slope. Is that x1, y1 and x2, y2? Okay. What's the change from y2 to y1? Did I go up or down at all? No. So that's 0 divided by what? How did I get from x to x? By going right, which is positive, right? So I had 0 divided by a positive number. Can I divide 0? How many pizzas are in front of me? 0. Fawaz, you can have half of it. How much pizza are you getting? 0. Everybody cool? So this is what we call a 0 slope. Because it has no slope, because again, it would be very difficult to ski. I've never called it anything but a 0 slope. Is everybody cool? So slopes can be 4 things. Positive, negative, infinite, 0. Everybody good? Now, this gets confusing for kids because slope has many, many names. On this side, we already know slope to be the rate of change. Yes? And that rate of change was always divided by 1. Correct? But slope is also a lot of other things. We know that it is m, right? From our equation. It is also, please look here, it is y2 minus y1 over x2 minus x1. Because you can see that that is the difference between the y's, isn't it? So that's another way to write it. We also know that it is the change. Triangle is a Greek word for delta, which means change. It is the change in y divided by the change in x. They use that in physics all the time. If you take physics, you're going to see delta all over the place. It's my mathy gift to you today. It is also the change in the dv divided by the change in the IV, because we're not always using x and y, are we? We could be doing distance and time. We could be doing height and time. We could be doing shoe size and height of person, right? So it's also that. Sydney. Yes, it is always, and that leads me to the last one. Thank you, Sydney. It's almost like you and I planned this. Because the last one, the one that you should always remember, the one that always works, no matter what the IV is, no matter what the DV is, no matter if we're using X and Y or P and Q or Z and M, what always works is rise over run. Always. And remember, rise is in math just like it is in English. If I were to rise from this seat, I would move up. I am stressing this because in 17 years of teaching, I have many students say, Mr. Myers, what's the rise? And then I do that. And then I rise to walk towards them like, oh, I remember now. If rise is up and down, what's the only other direction on a graph? Left and right. All right? Remember, up on a graph is what? Positive. Down on a graph is what? Negative. Right on a graph is what? Positive. Left on a graph is what? Negative. Is everybody good with the theory behind slope? Once again, if you've seen this before, you should be like, I got this. Shut up and let's move on. If you haven't seen it before, then you need to understand slope. Deep first. No, it's not x squared. It's x2. Yeah. How about you wait a second, see if that question gets answered? Because we haven't actually done anything with this yet, have we? Sydney. Yes. But negative is only a direction, right? If you can't wrap your mind around it, trust me, I've got a way to fix that. Just give me a sec. Here we have 4 functions, yes? Are those functions, do they look like this form? Do they? Output coefficient x constant. Output coefficient x constant. Do they look like it? Yeah. Excellent. So that means we can graph them, right? Because we know that this is the y-intercept, yes? Which means that is a starting point for every one of these lines, right? So I'm going to graph this guy with a red line. Where should I start? -4. 1, 2, 3, 4. Does everybody understand why? Stop me now if you do. It may seem frustrating to stop me on the very first thing, but it is not. It is much more frustrating if you let me do 15 questions and then say, I don't get it. So, does everybody know why the first dot is at that point on this graph? Good. So that is the one thing that we know so far. What is the other thing that we know in this? We know that m is slope, yes? Slope right here is the number 2, correct? How is the number 2 really supposed to be written, but math guys are too lazy to write it? Akash? 2 over 1. Once I have 2 over 1, isn't that a rise over a run? Is that 2 positive? So what's a positive rise? Up. So I go up 1, 2. Right? And it's rise over run, isn't it? So what's the run? Positive 1. What direction is positive? Right. And I put a dot. What do I do with those 2 dots? Connect them. Why? Because it's continuous data. Because I can take every single number in the universe, multiply by 2, and subtract 4. Right? Now you guys are smart kids. Since this is a line, and it's a linear function, that means if I go up 2 and over 1, I should hit the line again, shouldn't I? Did I? And then if I go up 2 and over 1, should I hit the line again? Did I? Okay, what if I go down 2 and left 1? Should I hit the line again? Yep. What if I go down 2 and left 1? Should I hit the line again? How long can I continue that pattern? Infinity. In which direction? Either direction. Is everybody good with the first one? Awesome possum. Let's do the second one. I'm going to graph it with a blue line. What is the y-intercept? Positive 1. So I put a dot on positive 1. What is the slope? There's no number there. What's the number that we don't write? 1. And 1 is really negative 1 over 1, which means I have a negative rise. Now, Sydney doesn't like that. Seems like a negative rise makes no sense to me. Okay, Sydney, I am working with you here. No, I didn't. I said it's a rise. So, if you don't like to think of, as Sydney says, rising downwards, no problem. We can work with that. A rise must be up then. So Sydney is going to go up 1, but since this is negative, if I use the rise to be positive, then what must the run be? The run must be the negative 1. Now, if you are okay with a negative rise, then you would go down 1, but then your run would have to be what? Positive, and it would be over here. And then what would you do with those dots? You would connect that line. Is everybody good? All right. Let's have a look at C, which I'm going to graph with a black line. What's different? There's a fraction, but we know that fraction is the slope, don't we? And we know that slope is always rise over run, don't we? And we know that since there's a negative there, one of those has to be negative. Does it matter which one? No. Negative 1 over 3 or 1 over negative 3. Where do I start my graph? At positive 5 on which axis, Amy? On the y-axis. 1, 2, 3, 4, 5. And now I must have a rise of negative 1 and a run of 3. So down 1, 1, 2, 3. Or a rise of 1 and a run of negative 3. 1, 2, 3. And what do I do with those 3 dots? I connect them. Is everybody good? Now, with a green line, which for some reason people can't do this one. What's the B? 0, because there is no B there. What number shows nothing? 0. So my y-intercept is 0. This is x plus 0, isn't it? What's the number in front of x? 1. Is it positive? So it must be a rise of positive 1 and a run of positive 1, or a rise of negative 1 and a run of negative 1 to make that line. Is everybody good? Yes, because if I rise negatively, which bothers some people, but that is a negative rise, yes? And I divide it by a negative run, 2 negatives makes what? Is everybody good? Which part, Amrit? 1/3 is a fraction, isn't it? And it's also m, isn't it? And m is also slope, isn't it? And slope is always rise over run, isn't it? Isn't rise over run written like a fraction? Well, there it is. -1 is in the numerator. +3 is in the denominator. -1 divided by +3 is -1/3. You could also write it this way, though. Because -1/3 is the same as 1 over -3, which is the same as -1/3. Pardon me? How did I label it on the graph? It's the black line. I went to 5, and I did both. I did a negative rise right here, and then a positive run of 3. Or I did a positive rise right there, and a negative run of 3. As long as one of them, either the rise or the run, is negative, you get your negative slope. Okay, Ekti. Let me get this straight. For D, did you say? C, yeah. Uh-huh. Yep. No. All right. Now, on this graph, I need to find the f of 2. Now, this is good practice for your test today, right? I can find that algebraically, can't I? Because the f of 2 works with function a, which was 2 times 2 minus 4, right? What is the f of 2 then? What's 2 times 2? What's 4 minus 4? 0. What would the ordered pair there be? 2, 0. Everybody agree? Check on the graph now. I can also get it on the graph. That was the red line, yes? Is 2, 0 on the red line? Right there. Yes, it is. Everybody with me? We found it on the graph. We found it algebraically. Got it? Let's look at the next one. H of 3. I'm going to change the view of this so we can keep it all on the screen at once. It is a little small, but it's big right in front of your eyes. So, H of 3. H is the black line, correct? H of 3 means I want the H of 3 is -1/3 times 3 plus 5. What happens to those 3's? Cancel. -1 plus 5 is what? 4, right? So what is the ordered pair there? 3, 4. Let's check on the black line if 3, 4 exists. 1, 2, 3. 1, 2, 3. Oh my good gravy, it's right there. Could I have found it on the graph? Yes, by going out to where x is 3 and up and finding it. Can I find it algebraically? right there, down here, which sooner or later, my, there. Is everybody good?
Oh, wait, how do you get 4? And so we gotta...
How did I get 4? I wrote it like that, David. That's how I got 4. Now, if you're asking me mathematically how I got it,
Yeah, that's one.
well, what is that? It's not an x anymore, it's a 3. So what happens to the 3 in the function? Or to the x in the function? It becomes,
3.
what is negative 1/3 times 3?
3.
Negative 1/3 times 3.
1.
Negative 1/3 times 3.
Negative 1. Negative 1. Wait, what? Catch up the threes, man. Negative 1. Oh.
That is 1/3. Multiply it by 3.
Not bad.
You have it now?
But wouldn't it still be 3 though? Wait, no. Oh. I got it.
What is negative 1 times 3, David?
Never mind. I got it now.
Okay. What's different in C and D? Look closely. Think about your test that you are writing later on today. What's different in C and D? You're looking for the X value this time because you've been given the output value, right? So if I was going to do it algebraically for G of X, wait a minute, G was what color line? Blue. If I was going to do it algebraically, G of X equals negative X minus 1, yeah? Negative X plus 1, right? Where does that 4 go? Does it go for X or does it go for G of X? G of X. So it's 4 equals negative X plus 1. Negative X equals 3, but I don't want negative X, I want positive X. So X equals negative 3, right? What's the ordered pair there? By dividing by negative 1. Same way I've been doing it since I learned algebra in the 7th grade. What's the ordered pair here? Negative 3, 4. Now let's go up to our blue line and see if negative 3, 4 is on it. Negative 1, 2, 3. 1, 2, 3, 4. It is. Because that line would go right through it. Could I find it on the graph? Yes. I would go up to 4, I would go across, and I would find the negative 3. Can everybody do both? And on this one, the f of x is negative 1. F of x was the red one. F of x equals 2x plus 4. But I don't want the f of x, I want the f of negative... Oh, I lie. Where does this negative 1 go? Does it go for x or f? It goes for f of x. 2x plus 4. Add 4 to both sides. 3 equals 2x, and x equals 3 over 2. Let's check, shall we? When f of x is negative 1, right there, go out here. Is that 1.5? Yes, it is. Can everybody work from graph to graph, equation to graph, equation to equation? Amber. Okay, the fraction has no place on the graph. It's giving you your slope, which is rise over run, okay? So I'm going to erase everything on here right now because it's all been recorded. You guys have all seen it. I'm going to erase this. I'm going to show you what is going on, okay? And everybody else, yes? 1/2, 1.5, 3 over 2. Okay, now I'm going to delete this, Amarit. We're going to work through one. I'm going to delete everything so nothing's on the screen confusing you. You subtract. Oh, good gravy. No. Oh, was it -4 in the original equation? Yeah, that's why. I wrote +4 because I didn't scroll back up. But I did the right thing. I still added 4 to both sides. So it's still right. I just happen to write plus 4 there instead of minus. People are looking confused now. Guys, this is the only thing I did wrong. I wrote that as a plus, even though I did all this work as if that was a minus, because I knew it was supposed to be a minus. I just wrote it as a positive. So you add 4 to both sides still. Negative 1 plus 4 is still 3. Okay. Let's erase it. F of x equals 2x minus 4. Solve it. Negative 1 equals 2x minus 4. How do you get rid of minus 4? Plus 4 to both sides. 3 equals 2x. How do you get rid of multiply by 2? Divide by 2. X equals 3 over 2. Okay. Now, Amrit, I'm going to show you this, and then it's going to be time for you guys to do work anyway. So, I'm going to write one that you haven't seen. Okay? It's nowhere on the screen. This is going to be totally new. And then we're going to work through it, okay? Q of x equals 2/5 x minus 5. Okay? Where do I start? Right, on which axis? It's the y-intercept. So I go down to negative 5. 1, 2, 3, 4, 5. Are you cool to there? All right. Now you're aware that that is m, correct? And you're also aware that m equals rise over run, correct? And that's written like a fraction, isn't it? The rise is on the top. Well, what's there? So the rise must be 2. What's there? 5. So the run must be 5, yes? So from this point, I rise 2. How do I go up? How do I move vertically in a positive direction? Up. So I go up 1, 2. But that's only the rise. I also have to do the run, which is 5. How do I move horizontally in a positive direction? Right or left? Right. 1, 2, 3, 4, 5. And that's where I put my second dot. That's where the fraction comes in. Okay? Now, I'm about to do that. Let's say I run out of graph. This dot's way up at the very top. I can't graph it. So I have to make it negative 2, down 1, 2. So I've got a negative rise, and 1, 2, 3, 4, 5, and a negative run. Then a negative divided by a negative still gets me positive. Okay? And then that line, as you can see, it's the same line. It just carries on. This dot? By going negative and negative instead of positive and positive. Because it's the same thing. If you can't do positive and positive, like let's say this was my y-intercept, can I go up from there? No, I'm off the graph. So I have to go down and left. Okay? Down and left is the same as up and right. Is everybody good? Okay. Now, on your outline, which none of you ever look at, page 384, I want you to use the x and y intercepts. For 362, I want you to use y equals mx plus b. So when you go to your work, you will see the first page is the 384 page. So that, use x and y intercepts. Don't use slope-intercept form. Use the x and y intercepts, which are x, 0, and 0, y. On page 362, which is the next one, here you can use y equals mx plus b. I want you to practice both of them. Okay? Now, as you can see, This will be helpful for your functions test anyway. Okay? Pardon me? No.
I just have a question. It doesn't matter which one you use later on.
If I don't specify what method to use, David, you can do whatever the heck you want. You can get out a chisel and a hammer and a stone tablet and work it out there for all I care. But if I tell you I want it done a certain way, you got to do it that way. Everybody Gouda?